Hello everyone, today we are going to make a resistant spot welder. The resistant spot welder is a device that used for welding metal surfaces. We will be making one out of a microwave transformer. Before we make this, I need your attention. Please do not try this at home or school if you're not a qualified electrician. If you're not a qualified electrician, please do not try this because it's involve high risk of electrical shock and it might result in death and electrocution. So have someone as well next to yourself because if something goes wrong, they can cut the power. So as safety comes first. For this project, you need to have safety equipments as voltage detectors, first aid kits, insulating sticks, portable earth short circuiting kits, insulating materials, protective equipments like gloves, helmet, insulated boots, safety boots, and these are required because it's involved high risk of electrical shock. So we need them for the safety. So what is in this video we will talk about the resistant spot welder, how works. We will work on its diagram, components, and then we will construct it. A resistant spot welding is a process that the connected metal surface points are joined by the heat obtained from resistance to electrical current. It is a subset of electric resistance welding. A resistant spot welder is a system that delivers low voltage, high electrical current poles. The weld electrodes are made of copper because copper has a low resistance to current flow that allows the electricity to conduct easily. Steel is used for welding as steel is very poor conductor of electricity and it will resist the weld current as it flows from the spot welder. The friction created by the current forcing its way through and the metal heats the weld area to over 2000 degrees. So by maintaining the squeezed pressure for a short time after the weld current is shut off, the pressure on the surface will compress the molecules in the welded material and it remains compressed as the weld cools. And this pressure results in much stronger weld. As you see here on the photo is the diagram of this process. The power alternative current or DC current comes from these conductor and then will flow from these electrodes. So these are the metal plates. So by forcing and connecting these two electrodes over these metal plates, the current will flow from them and it will result in high degree and it will melt these by forcing these two electrodes. It will melt these metal surface and then cooling them down will result in one welded area. Although we use single phase electricity in our example, but the three phase power will be more efficient than one phase. This will help for better welding as three phase welds the entire wave from starts out as single cycle, but it is followed by the second sine wave after the first one and the third sine wave is started after the second. Remember AC current as one sine wave per cycle, but the three phase current has three sine waves per cycle during the same period of time with three times sine waves. The three phase current is much better than the single phase. However, the three phase sine wave still alternate through zero, resulting in losses. To isolate the three phase and make the current more efficient, and it can be directed through a component called a diode bridge. A diode bridge allows current to flow through only one direction. So by using a diode bridge, a totally positive polarity current result, the process is called rectification. And the output that comes from this process is called direct current or DC. The DC wave is much smoother than the non-rectified wave. This results in less loss and makes the three-phase DC current better for welding than single-phase AC. But here we will use a single phase with a diode bridge. So this is what we are going to make. It will look like this. The components required: we need a transformer, we need a relay module for sending poles to turn on the transformer, we need a casing. It can be any case, but we use a power supply, computer power supply casing. We need a 10 wire, 3 to 4 meter. We need a diode bridge, a 200 amp diode bridge. We need a table arm. We need a swing arm table lamp. We use this arm for welding, and we need copper rods. We need some wires and soldering wire. Here I have drawn the circuit diagram. As you see, here is our 220 volt power supply. This is our power supply. This connects to a transformer. This is our transformer. This is the microwave transformer. I'm not quite sure how many windings are here, but we will use a secondary winding. On the other side, we will have two winds here, two rounds of the wire. So as you see, from the one side of the transformer, there is a switch. This wire is disconnected by a switch. There's a relay switch, and here we have a relay module. Here is our relay module, which is connected to a switch that sends the signal to relay module to turn on and off this relay switch. So on the other video we explained how we make a relay module. You can visit the link on description to know how it works and how you can make one. But this is the way the relay module, we place it here to disconnect and connect the power from the transformer. So on the other side of transformer, we place a diode bridge. This diode bridge directs the current. This diode bridge, we said this diode bridge has to be at least 200 amp rated diode bridge. And from other side, here we have our electrodes. These two wires going to diode bridge, and these two coming out of it. So as we can't show electrodes here by this software, so what we did, we placed a LED, so with the resistor. So this LED will be showing how our electrode works. We assume here this is our first electrode, and this is our other electrode, and we assume this LED is our welding plate. So the current comes from these wires, and it will be weld here. So let's simulate this. I will press this relay module switch, send a signal. As you see, I send a signal, and you will see the current, AC alternate AC current. You will see it moves here. On the other side, the current comes from these two sides, and there is the diode. Here is the current impact. Here is the, you will see a welding, but you can't see welding. I can't show it with the software, but I have put an LED. It will show you how this will work. So that LED which is lighting up is our welding. This is our weld section, and I will show you how it will work. As well, this was our 5 volt power supply. We set this to 5 volt. This power supply is a 5 volt power supply. We can take it from 220 and put a small power supply from 220 to 5 volt, and this will be used for this relay module. You can see we have a broken microwave here. What we do, we will open this microwave. microwave is open, what we need to do, we need to take out this transformer. We need this transformer. You need to be very careful with the electronics inside. There might be capacitors still has a charge, so and be careful with this transformer. Make sure you unplug the microwave. As you see here, I have taken out the microwave adapter. This adapter has two coils, primary and secondary. The primary winding is thinner than the secondary. So what we do here, we will only use a secondary transformer and will remove the primary coils. So this is 250 volt transformer, 50 hertz. You need to be careful with this because it's a little bit because it's dangerous. Here I'm removing the primary coils. You can use a screwdriver or drill. Now I have removed the primary coil, and we will use these two holes to run a thicker wire for drawing higher current. As you see, these two wires, we will connect these two wires to the high voltage like 240 220 volt. Here I have started to run the three wires. You need to run one thicker wire about 10 to 16 mm, but I have run three wires. I will join them outside, so they will as a one wire. You need to run do one winding, one round, run them one or two round, and here I will use this power supply as a casing. I will place this transformer inside this power supply. Keep in mind, running two round of wire will give us less voltage. That's what we want. We want less voltage, but how to get a higher current is by using a thicker wire. So the thicker wire will draw more current. So it's two round of 10 to 16 mm wire, which gives us enough amp to make a battery spot welder. So start removing the screws from power supply. Remove this circuit board inside of it, and make the casing of this power supply empty. Take out everything, but leave the high voltage plug and the cooling fan in, because we will use them in future for connecting high power. Hey everyone, as you see, I made two holes here, and these cables comes out from here. This is our fan, this is our power supply input, and this is the wire that activates the welder, the motor, the transformer. So the way you see is like those wires came out of those holes, and so for the other section I have cut the power supply input. I cut the one wire, which is live wire. So what I'm trying to do is to use a relay module to activate and deactivate the transformer. So what I want to use is a relay module. This relay module I will be connecting to this power supply wire to disconnect and connect the power, high power. So, and this relay module will be connected, it will be activated by user when they're using the application. Check the diagram how it's made, so you don't have to, you can make it from the diagram. One more thing I will be using is this item is I will use this as a camera holder. This is a camera or the microphone holder. This is an arm. This arm can be open and closed. So this is a mechanic arm. I will put this here So here I have connected my 5-volt relay module. This is the 5-volt relay module. These two wires are the high voltage wire, 220, and this is 5-volt wire. So this is 5-volt relay switch. We will give 5-volt, and this last pin is our signal pin. So we need 5-volt power supply. We need to put a 5-volt power supply in this power supply. For that, we will take 220 volt, convert it to 5-volt, and give that 5-volt to relay switch. So for that, you need to have a small transformer here to make a 5-volt of the 220 volt, or make another circuit boards that is a combination of capacitor and diodes to convert 220 to 5-volt. But we will use a small transformer inside to provide 5-volt for the relay module. So if you want to know how we make relay module, or where to buy it, you can find one online, and if you can't find it, watch our relay module reverse engineering. It shows how you can make a relay module from a relay switch, a transistor. You can have this relay module and turn on and off applications, even like this transformer we will use on this video. So the link is on the description for making the relay module. You can visit that link and make one relay module for this project. Here, as you see, I have installed the relay module inside this casing. The relay module is connected to 5-volt adapter, which you see on the right side. That adapter gives 5-volt power to relay module, and relay module will connect the transformer to 220 volt after a signal is received from the user by relay module. Okay everyone, this is the closed box. These wires are coming out of transformer. I've attached this arm. This arm is screwed to this body of the this casing. Is screwed very tight. You can use this arm, turn it around 180 degree. It goes up and down. It's very flexible. You can easily turn around, push it down, push it up, but the body is moving. You need to fix that body somewhere, so you will easily move the arm around, and the body will not move. So here at the end of this arm, we will install two electrodes, the two wires coming out of the box, which carries high amp current. They will come and will be installed on this arm. And as you see here, this is the completed module. The red wires are connected to a transformer which carries high current. These two wires coming out of the box and ends to the end of the arm, and there is two electrodes, which is copper wire. This arm, and the end of this arm, is fully rotatable. You can turn it around 180 degree, and even those two electrodes can be set up to a distance. You can lose the screw which I used, and you can adjust the distance you want. And this is the switch. This switch is used for relay module, sending pulse to relay module, which activates the transformer. As you see, fully flexible at end, up, down, around. Fully rotatable. This is the wire which is used for relay module. Here you can lose the arm, tight the arm. Okay everyone, let's do testing. I have connected resistant spot welder to a power supply, to power. So now Okay, so when I press this switch, it will turn on the transformer, the spot welder. You will hear a noise of so this is a metal surface, and I will be welding this on this metal surface. Is both of them are metal, and I'm going to weld them. So I can place it on each other like this, and then press this button, and it will work. I need to push some put some pressure. So as you see, it welded it here. You see they are welded. What I do now, I will be disconnecting this. I will weld this on the top of a battery. So let's do this with the battery. I need to put the distance of the electrodes. I need to put them very close. Okay, there is. Let's do this now. Yep, it's a quick joint. Let me do it again. Because I'm recording the video, I have to be focusing on this. Okay, now it's completely welded here. As you see, it's completely welded on the surface of this battery. Okay, so let's test this welder, how strong it is, by shorting this two electrodes. As you see, it's completely melting. It melts that wire. The degree on this melting is more than 200,000 degree. So let's do welding on this surface of this battery. You need to connect the electrodes for very short time on the surface of this battery, because placing them for long term might heat up the battery and might damage the battery. Okay, it's done. It's strong. Well, I think the current is a little bit too much. I need to hold it for very short amount of time, like a second or 2 seconds, or less than a second. So it will weld the metal of the surface of the battery. Let's give it another shot. Yep, as you see, it's welded, and it is enough good for a battery welder. So you need to do 1 or 2 times, maybe 2 spot or 1 spot, to make it to weld it enough. Okay, yes, we are okay now. Both are welded perfectly. So as you see, this it works perfectly with this spot welder. You can weld batteries together, and it is very strong. Thank you everyone for watching my video. Please press like if you liked it. Please share and subscribe to my channel, so I will be making more videos like this if you liked it. So please subscribe. Thank you.